what I'm going to do with the values of this variable that are meaningful is try to put them all on the same scale. I have a choice here. I could try to make a new variable as I'm doing, which is number of times per year you check your blood sugar, but I could also try to put everyone on the scale how many times per day do you check your blood sugar, and that'll just be a fraction for some people, or how many times per week, or how many times per month. The key idea is to make it the same for everybody so that I can actually take the mean of this variable and have that be a useful piece of information. First, I'm going to handle the people whose current responses to the blood sugar variable are listed as 888, which means they said they never check their blood sugar. So for my new times per year variable, I'd like those people's values to be recorded as 0, not NA anymore, but 0. So I'm going to take a subset of my new variable. Here's my new variable. If I were to print this out on the screen, it would be a lot of NAs, right? Many, many NAs. But I'm going to take a subset of it. Currently, the subset also consists of NAs, but I'm going to take a subset of my variable and fill it in with zeros. So this is how you're going to recode variables in R. You say new variable where I'm thinking of a certain subset should be equal to a certain thing, such as 0. Now let's look inside the brackets and see what subset we're talking about. First of all, we're saying this is going to be the subset of people where the blood sugar is set equal to 888. So that's certainly what I'm looking for here. But I also have this other part. Not only do I want blood sugar to be equal to 888, I also want the blood sugar variable to not be missing. Why is that part necessary here? Well, it's not always strictly necessary, but it's a good habit to get into when you're recoding, to do it this way, to always start with not is NA that variable. The reason is that if I look at the responses to this statement right here, BRFSS blood sugar equals 888, that's going to be a bunch of trues and falses. It'll be true when people have their blood sugar equal to 888, but depending on the type of data set, sometimes it'll also be true when the actual value is NA. Again, if you ask a question about whether a particular variable is equal to something, sometimes the NA values will just answer true by default, even though you didn't want them to. And I don't want to turn all the NAs in my variable equal to zeros, because that's the whole point, is to make a distinction between those. So what am I doing? I'm saying my times per year variable, where the blood sugar variable is not NA and the blood sugar variable is equal to 888, set those equal to 0. So I'm going to go ahead and run that line of code. Now I'm going to start to deal with the numbers other than 0. So what the codebook said is that if people gave a response between 400 and 499, that meant that they were telling us how many times per year they check their blood sugar. And if I go look at the codebook, I can see that there were 562 people who provided the information this way. It's important to check that before I try to print it out into the screen, because 562 will fit at least reasonably on my screen. I'm not going to be printing out 400,000 responses here. So what am I going to do? I'm just going to look for a moment at this subset of code. So let's see what it says. It says, give me the blood sugar variable where the blood sugar variable is not NA, and the blood sugar variable is bigger than 400 and the blood sugar variable is less than 500. If I run that little bit of code, there's going to be 562 values here. Here are all the responses that fell in that range and that weren't NA. As you can see, people give responses like 402, 404, 403, etc., etc. It's a couple 499s, which are maybe worrisome. Why did someone say they check their blood sugar exactly 99 times per year? Maybe they actually give a number bigger than 99. But that's what this variable is currently equal to. Now, if I want to know what number I should write down for the actual times per year, I need to subtract 400 from all these variables, right? Like this first person actually checked their blood sugar twice per year. So I don't want to write down 402, I want to write down 2. So here I've got a minus 400 after this whole statement. So here's the number of times each of these people said they checked their blood sugar. And I want to use these values to fill in the corresponding values in my new variable. So here's my new variable, BRFSS times per year. And what this says is my new times per year variable where blood sugar is not NA and blood sugar is bigger than 400 and blood sugar is less than 500 should be set equal to the blood sugar variable where blood sugar is not NA and blood sugar is bigger than 400 and blood sugar is less than 500, but subtract 400 from that. In other words, both these sets of brackets, before and after the equal sign, refer to the same subset of the data. I'm replacing some of the NAs in my new variable with the actual variable values from my old variable, but subtracting 400. And after I run this piece of code right here, then if I go ahead and make a table of my new variable, you can see that here are my zeros that I filled in before. The NAs are omitted because this is a table rather than a summary, but you can see that these are reasonable responses, perhaps except for some of these 6 people who said they checked their blood sugar exactly 99 times per year. People who gave responses between 301 and 399 were giving their responses in terms of times per month. So what does this whole statement say? It says, get my new variable where blood sugar is not NA and blood sugar is bigger than 300 and blood sugar is less than 400 should be set equal to the blood sugar variable where blood sugar is not NA and blood sugar is bigger than 300 and blood sugar is less than 400. Subtract 300 from all those values, right? Because if we were to look at those, they'd all be numbers starting in with 300, like 301 really means 1. And then this whole thing would give us the number of times per month. And since I'm trying to create a times per year variable, I'm then going to multiply that whole number by 12. So for example, if I told you I check my blood sugar once per month, my value was written down as 301. So you want to subtract 300 from that to get 1 and then multiply it by 12 because my response should be 12. So if I run that whole line of code and look at the results, you can see that, again, this table telling me how many times the times per year variable, the times per year variable is equal to each of these values. You can see there are a lot of people who said they check their blood sugar once a month, right? There's 650 people like that who now have 12s here, so that's good to know. 9 of those you can see are from the times per year, but a lot of additional people were added when I added in the times per month. Now I'm going to similarly deal with the people who reported their blood sugar in terms of times per week. You can see what we have to do with these values is subtract 200, then multiply by the number of weeks in a year. So if I run this code, then again I can look at the table and then you can see that it's filling in. There are more values here than there were before. Then I have times per day, so I have to take those, subtract out 100, multiply by 365. I suggest looking carefully at this code to make sure you understand each statement that's in here, but you may not want to try printing it onto your screen because if you look here, there were almost 16,000 people who gave their response in terms of times per day, so that may not be something you want to look at on your screen. I can run it though, and I can make a table, and now I'm starting to have useful information about how many times per year each person check their blood sugar. In fact, now I can actually make a histogram of it. The only problem is this histogram looks a little bit crazy. Like there is clearly some very, very high values here. And if I look again at my table, I can see there are 3 people who I've calculated they check their blood sugar 36,000 times per year. 8 people, 35,000 times per year. What does that correspond to? Let's look. If we take 36,135 and divide by the number of days in a year, those are people who are saying that they're checking their blood sugar 99 times a day, and I just don't think that's the case. So I'm going to take those people out. So I made an arbitrary decision here to group the people who said they checked their blood sugar more than 10,000 times a year. So I arbitrarily made a cutoff here. I'm going to group, I think those are mistakes. Those are the people I honestly think are mistakes. And I'm going to group them together with the people who didn't know or refused to answer. In other words, I'm going to put an NA there. And to make this work best, I'm going to edit this. It should say is NA BRFSS blood sugar and time per year greater than 10,000, set those equal to NA. And that should work. And if I do that, now I can make a histogram of these values. That actually looks reasonable. You can see how often people are checking their blood sugar in terms of times per year. I can summarize it, and now finally I can tell you that on average, people who responded to this question who have diabetes check their blood sugar on average 495.6 times per year, which makes sense because it's a little bit more than once per day. I'm also going to show you how to clean up a couple other variables. There's a variable in this data set called delay med. So let's first look at it in the code book because it doesn't mean anything unless we look at the code book and see what it is. Let's go look at delay med. Here it is. So this says, other than cost, there are many other reasons people delay getting needed medical care. Have you delayed getting needed medical care for any of the following reasons in the last 12 months? So we have things like you couldn't get through in the telephone, you couldn't get an appointment soon enough, you didn't have transportation. No, I did not delay. That's the most common response. So what I'm going to do is I'm going to group together the responses that I think are similar. Perhaps I want to use this as a predictor variable, but I don't want to have so many different categories. I actually think that not being able to get a soon appointment is similar to not being able to get through in the telephone, for example. So I'm going to I decided to create a categorical variable that has 3 possible answers or NA. So if it was the doctor's office's fault, like you couldn't get through on the phone or they didn't have any open appointments, I'm going to make that one category. If the reason you couldn't get to the doctor is your fault, you didn't have transportation, that'll be a different category. If you actually did not have a delay getting to the doctor, that's a different category. And then I'll use NA for people who are missing, refused, don't know, other, etc. So the process is similar. I'm first going to create a variable in my data set called delay clean that consists of NA lots and lots of times. And then I'm going to start to fill in parts of it. So I'm going to make this delay clean variable where the original delay variable was less than 5, set that equal to office at fault. Because if I look back at the code book, the first 4 reasons listed here all imply that it was the doctor's fault that I wasn't able to get to my appointment. So I'm going to group those all together and say office at fault. Note that equivalently I could have done it this way, and this may be more useful if the original variable you're dealing with has text responses as opposed to numbers. This says my new variable where the old variable was equal to 1, or the old variable was equal to 2, or it was equal to 3, or it was equal to 4. All of those should be office at fault. Then I'm going to say when the old variable is equal to 5, set the new one equal to no transport, because that said that was the value of the variable indicating you didn't have your own transportation. If the old variable is equal to 8, that is where you're saying there was no delay. Then I'm going to stop there because I want everything else to remain NA. So I'm going to go ahead and run this code. And I can now look at this variable. First I'll look at it using summary because I'm curious to know what happens. And what happens is I don't find out how many NAs there are because it's a character variable. So the summary command does not work for character variables, but I can make a table using is.na. Okay, and that tells me I do still have lots of NAs. I have 147,611 of them. And if I go back and look here, that's about right. I started with 103,000, now I have 147,000. That makes sense because I tried to add the refused, don't know, and other to that category. And it's important to check this, that I didn't accidentally remove all the NAs because I wanted there to be some NAs. And note that in this version of cleaning a variable, I did not go through the step of each time saying new variable where old variable is not equal to NA and equal to some other value. I didn't do that. So I needed to check and make sure that I didn't accidentally turn all the NAs into one of these categories, and indeed I didn't. But I can make a table of this variable. Now before I do that, I want to explore what values it can take on. So I showed you a moment ago when I tried to summarize it, it didn't work because you can't summarize something that just consists of words. And this variable that I made is equal to the words office at fault, no transport, or no delay, or just missing. So importantly, there are different types of variables in R. This is something that you need to know. There are numeric variables that consist of numbers that you can add and subtract, etc. There are character variables that are strings, so something like the list of everybody's name. Then there are factor variables, which can be numbers or strings, but importantly, it's a categorical variable and R will handle it accordingly. So there are certain operations in R that you can only do if you have a factor variable. For example, if you are trying to make box plots based on some grouping variable, that grouping variable has to be a factor, not a number or a character. Similarly, if you're running regression and you have a predictor variable that you want to treat as a categorical variable, it's got to be a factor first. Same thing if you're using the ANOVA commands. There's also a particular kind of date variable that we'll talk about in a moment. To find out what kind of variable you're dealing with, you can use the class function. So if I do this, it tells me that this new variable I made times per year is a numeric variable, so that's good. And I can confirm that with this command is.numeric. So I can ask the question, not just what is the type of variable, but particularly, is this a numeric variable? Is.numeric times per year. Yes, it is. So that's good. So as I'm trying to debug something or as I'm trying to decide what commands to use for a particular variable, it can be useful to check that it's numeric if you really think it's numeric. What about delay clean? Is that numeric? No. All right, so what kind of variable is delay clean? It's a character variable, and I can confirm that. Is it a character variable? Yes, it's a character variable. So this is useful to be able to understand what kind of variable I have in order to possibly turn it into a different type of variable. So as I just showed you a moment ago, when I made this summary on the character variable, it didn't work. I can make a table, so this does work. I can see how often this new variable was equal to each of these values. Note again that the table command drops the NAs, which is not that desirable, so you have to be checking for the NAs as you go. But what I really want is to have my clean delay variable be a factor so that I could, for example, include it in a regression model. So I showed you these commands, is.numeric, is character, where you ask the question, is this variable a particular type? But the as command will turn the variable into a particular type. So if I make a new variable, delay clean factor, and set that equal to as.factor delay clean, now we'll have a factor variable. The table will look exactly the same. I didn't change that part. But now if I ask the question, is this a factor? The answer is yes, and so I can go ahead and do things that require a factor. And sometimes when you're looking at an error, when you're trying to do a particular thing in R, sometimes it'll say this variable isn't a factor. So now you know how to check that and how to fix it if that is indeed the case.